Hi everyone, this is Lionel here from Learning Machines. It's great to be here at AI Expo Africa today, and I'll be telling you about robust MLOps and why it's a key driver for your business success. So a bit more about us. We do three major things: big data, everything associated to that, from running big batch jobs to event processing, millions of events, everything associated to handling of data at scale. Machine learning, making use of that data and assisting our customers in doing that, as well as assisting in the journey to cloud with our certified cloud solution architects. Some of the projects we do, we work with some of the largest organizations in South Africa that handle the most data. And we've been doing Apache Spark since about 2016. We run on-premises clusters, Hadoop clusters for some of our customers. We build and deploy event-based infrastructure, handling truly millions of events and acting intelligently upon those events. AI, ML, from propensity models, recommendation engines to churn to scoring models, whatever the case may be. Very varied set of NLP, typical machine learning solutions, deep learning solutions, etc. And then we also do workshops with our customers. We've done a number of these that have been really successful and valuable to our clients. And what we do is we work with, for 2 days, we spend time with your software architects, your data architects, and introduce and discuss with them the latest and greatest in tools and techniques for handling data at scale and doing machine learning in a reliable way, and being able to start democratizing the use of data and machine learning across your organization and doing this effectively. Also training, trained truly thousands of folks in South Africa, and as part of spreading the broad understanding of data engineering and machine learning in your organization, and this common language that is necessary for the organization to start adopting this at scale, where you should be starting to head towards now. So why machine learning? Machine learning is interesting really now because we're starting to create the organization as intelligent agent. This is really happening now. I remember working for Oracle many years ago, and I was giving talks about real-time marketing. And, there was a bit of hype around those things for many years, but I have to say the reality has arrived. So intelligence agents, what are they all about? So intelligence agents have goals. And in order to achieve those goals, they need to know what is going on in the world. Sensors, what is going on? Being able to see, hear, smell, taste. And not only must they be able to see what is going on around them, they must have a model of the world to know that, okay, yesterday I was somewhere and I got food. Now today I would like to be able to get there again. It must use a model of the world to be able to pathfind back to that location where it was yesterday for food. And in terms of goals in raising offspring, etc., etc. So one needs to have a model of the world to understand, based upon what is happening now and what my goals are, I need to be able to decide what action I'm going to take. So this is really what intelligent agents are all about. And of course, the key thing is, intelligent agents must become better and cope with change. So they must be able to learn. So intelligent agents, organizations, really? Well, you don't get a program guide anymore, TV program guide every week. The TV program guide has become an automated intelligent agent. It understands people, compares them to each other, and creates a personalized TV program guide for you. So it's an intelligent agent TV channel. 2-ton Teslas driving around by themselves, definitely intelligent agents. Goal, get you somewhere safely, don't crash, sense everything that's going on, have a model of the world and how to act, etc., etc. Intelligent agents. Now, intelligent agents in typical sort of service organizations, where there are events that are occurring. Your customers have just visited your website. They clicked on these pages. They went to the app. They interacted. They posted about you on Facebook. They did certain transactions. They interacted with a call center or any other thing that can be happening, whether it's data from inside your organization or external to your organization. In effect, the more data that you can make available to your organization as intelligent agent, the better. It must know everything that is going on. Not only must it know everything that's going on, it must create context around what is going on. So if a transaction occurs and a customer, let's say their balances, for a banking case, their balances dropped below a certain amount, and you've pre-approved them actually just a week ago for overdrafts, you'd like to know that at that instant to be able to offer them an overdraft should they want to take that up. And you can have propensity models, etc., that can assist in making the right decision about what to do based on your organization's enriched understanding of what is going on. And then you need to be able to act. What does act mean? Well, it means integrations. So if you decide that you want to push a message to your app, to your customer on the app, well, then you need to be able to do that. Or SMS or into your call center, or take some action inside of your organization systems of record. These are all integrations that need to be done to enable your intelligent agent to not only see what's happening, create context around what is happening, make a decision towards achieving your organization's goals, and being able to execute that action. So that is what the space of intelligent agents in organizations is all about. And we are building this for organizations across South Africa and achieving real significant success in doing this. So these intelligent agents are sometimes not as intelligent as we'd like them to be. And if computers start going bad, they do so extremely fast. And very bad things can happen. Either 2-ton Teslas drive off cliffs, or the computer says no, and people that should be getting credit are not getting credit. At the end of the day, though, the computers might be messing things up at great speed, but humans are held responsible, accountable. So what is the space in which we need to be able to be excellent at machine learning and data engineering, but also make sure that compliance, regulatory, and customer service are maintained at a good level? It's the machine learning lifecycle. So going from business understanding to getting the data to be able to train the machines about this use case that you have, to being able to develop this model, to being able to verify that it's acting as it's supposed to be, to being able to deploy it, and then monitoring it so that you can be sure if your model is starting to lose the plot, if the world is changing around it and it is not able to cope with the fact that the world is changing. Now, there's a lot going on in this slide. Doing it for 1 or 2 people, not so bad. Once you get to 50 people in your organization really doing this, becomes difficult. And some of our customers have more than 1,000 people doing this. And then it is quite challenging. And MLOps is standardizing and making this efficient across an organization and being able to do it effectively and safely at scale. So how does one go about that? Well, one might think that you have to really spend your time in this green portion here. So it's, building the machine learning, applying machine learning code to your data. Actually, the machine learning code is normally only about 70, maybe 100 lines of code. What is really difficult and where you will spend the vast amount of your time is working with data, building infrastructure to handle this vast amount of data, and being able to do integration so that your intelligent agent organizations can act upon the world. And just managing all of these different models as well and making them reproducible and so forth. That is where it's engineering. A lot of your time will go into, the vast majority of time will go into engineering. So what kind of engineering? Why is it different? Well, first of all, it's not only software anymore. It's software, the little program that creates the artificial brain, must be combined with data. So data must sort of be version controlled. It's as key as the software, and this is a big change. So having this data lake, which can handle tons and tons of data, possibly in conjunction still with your different data warehouse technology, which is data for the humans, together with something called a feature store, which is making data available to your data scientists in a simple and easy fashion, whether it be for training or whether it be for inference time. Models, managing the development of all of these models and tracking them, making it reproducible, being able to deploy them, versioning, etc., etc. It's not quite source control anymore. You can't do commits the whole time and so forth. It's a different thing that's going on when you're starting to develop hundreds of these models, and there are many people involved. So you need some kind of a different artifact management tools to assist with this across your organization. Code, the GitHubs and so forth still work very well for code, and the usual deployment DevOps processes still work very well. But then there's also more metadata that needs to be captured either within these tools, but also extracted and provided across the organization to manage this entire process of MLOps at scale across your organization. So some of the tooling out there, for data lake, data warehouse, and if you're lucky enough to approach a Lakehouse, you use technology like Databricks' Delta Lake. Well, it's actually open source, so it's the Linux organization that is running Delta Lake. Notebooks for your data engineers, data scientists to start, to build their models and deploy their models, which is a bit different from the typical IDEs. So there's some work to make this environment. It's almost like you need to enable many in your organization to do some coding, but in a friendly way. And IDEs are not particularly friendly. So one really needs to put work into being able to, do the amount of coding necessary to democratize machine learning in your organization, but not quite as scary as having to learn Java. So it's a bit of a balance to get right there. Feature stores like Tecton or Logical Clocks or SageMaker's feature store or Databricks' feature store. GitHub, same as always. MLflow, which I'll talk a bit more about, to really enable you to manage this model lifecycle. Kubeflow for serving up models and multi-on bandits and so forth, and Fiddler, tools such as Fiddler to understand when data drift occurs or outliers or the world is changing around your models. Now, there's a ton of tools. This is a very fast-moving space. And keeping track of all this is a bit of a challenge. What is a tech landscape in which one has to do this and compete? So in your organization, you typically have your systems of record, the SAPs or the Oracle ERPs, or maybe your Salesforce systems as well, or if you're in a bank or insurance company, some kind of a mainframe application, the system of record. Then there's systems of engagement. And this is basically the digitization process that has occurred over the past couple of years. There are now apps and websites and all manner of ways of interacting digitally with the organization. And these are starting to become quite mature. Then there are systems of insight. Being able to take all this digital data, all these interactions, understand them, learn from them, and become better as an organization in serving your customers. And once you make these decisions, these systems of insight, well, then you need to take action. And how can we have more of the organization taking action in an automated fashion as opposed to humans taking action? So systems of automation. Now, if we look at these two, systems of insight and systems of automation, this is really the competitive landscape over the next 10 to 20 years. This is, you're going to win or lose in that space. And it's rapidly changing. So doing this on premises yourself, getting all these best of breed tools, combining all of them, we've done a lot of it. It is hard. It is. I have a lot of respect for the people that need to run on-premises clusters and event handling systems and trying to sort of create the intelligent agent organization on-prem. It is extremely tough, and everyone in those groups work extremely hard, but it is just really tough to compete with the cloud vendors. They have the latest solutions, the latest versions, all pre-integrated, enabling organizations to focus on the business value as opposed to the really complex tech of making all this work. So the cloud is definitely the way to go for systems of insight and systems of automation. So why is this only really starting to happen in South Africa in the past 2 years in terms of the cloud journey? Well, at least for the customers that we work with, because they're critical to South Africa's infrastructure. If a fiber optic cable was cut, South Africa would come to a standstill if all our banking infrastructure was located offshore. So we couldn't really do it at a broad scale. Some of the smaller banks were lucky, and it's not as risky as they might have, if they go down. So they migrated early on, but the big banks, too risky for South Africa to have all of that sitting offshore. But now we have local points of presence, and the race is really on to compete in the systems of insight space and the systems of automation space by moving those capabilities into the cloud as quickly as possible. So if the cloud vendors are integrating the technology, and the machines are sort of automated and intelligent agents are doing things for us, what are we going to do? Well, the job of people is to prepare data for the machines. Thanks, Morpheus. Yes, it is quite tough. Our suggestion, Databricks. Databricks is a unified data and analytics platform in the cloud. They must be doing something right, because AWS and Microsoft invested $1 billion in them in February. I guess it's a bit of a case of if you can't beat them, join them. And Databricks are the originators of some of the most popular open source libraries in the data and machine learning space, from Apache Spark to Delta Lake to MLflow. Mature, fast-growing, already large cloud vendor. And so let's look at where Databricks provide solutions and make life easier for you. So on the data processing side, how we see it is data for humans and data for machines. And these two are not quite the same. Data for humans, you want your fact tables, your dimension tables, you want your drill down and slice and dice and visual representations. Humans cannot deal with thousands upon thousands of facts. Machines, on the other hand, love facts, thousands upon thousands of them. And we build these data lakes to enable to make the data for the machines. And then we have the data warehouses, which are capable of doing upserts and so forth, which are necessary for fact tables, dimension tables, etc. And it was the case that the data lake technology just couldn't support data marts. It was just not possible to do that cap theorem, etc. On data lake technology. But in the past 2 years, this has now changed, and we can have what Databricks coined the concept called the Lakehouse. So data lake combined with the data warehouse, Lakehouse. The technology is now at the point where across potentially thousands of machines on open source technology, we can serve both data for the machines as well as data for humans. And we can update, insert, manage these fact tables, these dimension tables, and the performance is good enough to allow slice and dice, drill down, etc. on one single platform on open source technology, object stores, and that can scale across potentially 1,000 machines. So the technology has come a truly long way in the past 2 to 3 years. And it's prime time now to not have 3 or 4 data systems, but to have one on open source technology on a distributed scale. And what enables this is technology such as Delta Lake and Delta Engine from Databricks. So that's one thing. We can integrate our data into one data management platform, data for humans and machines. Okay, so what do we do now? We want to use this data. We want to build machine learning models. We want to deploy them, etc. Well, Databricks provides that as well. So all the way from providing a feature store, which is taking data from your Lakehouse and putting it into a managed store of features, thousands upon thousands of features. Now, for some of our customers, we produce up to about 60 billion features per week, millions of customers, thousands upon features. It becomes billions very quickly. So how do you make this easily available to people in your organization? And how do you track what is being used where and what versions and so forth? Well, Databricks does this for you. It's quite amazing, really. As you're building your model, it tracks which features are going into what version of that model. And when you want to deploy a new version of a model, the folks that want to deploy the model don't need to know about the feature code. The feature code comes with the model. So if you're upgrading your model and it uses 50 new features from the feature store, in your deployment process, they just become part of the deployment process. So it's really quite amazing what they've done, and you can see which features are used in which notebooks, which models, etc. So you can manage deprecation of features, versioning, etc., etc. It is critical. So if, now the data is not only for executive reports, but it actually driving the automated intelligence in your organization. You need to manage data like it's code. And the feature store is the steps along the way of being able to manage data in a way that is more similar to code, but also making it very simple. Okay, so now you've got the data in your feature store. You want to now build your machine learning models and deploy them. Databricks provides MLflow and their notebook experience where they've pre-integrated PyTorch, TensorFlow, scikit-learn, various approaches to building machine learning models. And not only can you easily build them in this wonderful notebook environment, you can track everything that you're doing. You know, the versions, the hyperparameters that you're using, your libraries that you're using, and you can use a project concept to package your work. And this is the kind of a, it works on my laptop problem. Well, with MLflow projects, you won't have that problem. You will be able to reproduce the performance of some model that you've trained, that someone else has trained in your own project environment, because you can get the data, you get the libraries, the versions, the hyperparameters, everything that you need to be able to reliably reproduce some training performance that someone else managed in your organization. Critical if you want to manage your machine learning MLOps process as artifacts in your organization. And when it comes to deploying them, you've got a myriad of options in Databricks. You can, deploy them in the cloud as RESTful services, or Dockerized deployments on-prem or in the cloud. You can deploy them in a batch fashion. Very, very simple with snippets of code to make it easy for anyone to use that model. And as I said, using the feature store, it even integrates the code necessary to be able to get you the features to make a model deployable. So MLflow really assists greatly in managing the entire process of going from data all the way through to deploying your models, and doing this at scale. Yes, because the technology is now able to support fact tables, dimension tables, and the slowly changing dimensions, etc., and has the speed to not only do large batch jobs, but also respond quickly to ad hoc queries. You can now run your BI tools straight on your same data lake technology. And the Databricks platform enables you to manage your data all the way from source, all the way through to well-managed fact and dimension tables, ensuring data integrity all through this. And in fact, what's sort of happening is the distributed data systems are becoming a little bit more like relational databases. So it took time, but we are really there now. Obviously, you can't do transactional systems on there, but machine learning data for humans and data for the machines, it is possible now, and you really should be going this way if you want to reduce your costs and make your folks working with data and machine learning and BI more effective and efficient. So Databricks, really, it'll save you a ton of heartache. You'll be able to focus on the business solutions as opposed to focusing on technology. Learning machines, we're a Databricks partner. We've been doing Spark and associated technology since about 2016. We have many solution architects and also cloud certified solution architects. So if coping with this world is feeling like the white walkers are on your case, give us a call. We'd love to help.